Alrighty, so I actually went with the Gauteng paper for the functions questions, mostly because it wasn't in necessarily the order that we're used to. And so it was just quite nice to have your brain challenged in the sense that usually we go into a functions question expecting to answer a basic hyperbola question first. Then we expect to answer a combination question, which is usually a parabola and some other function. 80% of the time a straight line, but it could be a hyperbola, an exponential, something like that. And then we go into the third question where we expect an inverse function type question. Whereas for the Gauteng paper in trials, it was actually the inverse function first, then it dealt with exponentials and inverses, and then it only dealt with, if I remember my functions correctly, and then it only dealt with the combination question. So this was just a little bit different in terms of how it was set up, and just it's nice to see things being presented differently, because I think that's sometimes what trips us up. We expect one thing, we get another thing, and then we panic. All right, so, let's have a look. So, as we already know, question 1 will be algebra, question 2 and 3 will be sequences and series, question 4, 5, and 6 will be functions. Okay, that this general setup of your paper remains the same or remains consistent. It's just how these questions are phrased and how they're asked us. So it says the graph of f of x equals ax squared, where x is less than or equal to 0, sketched below. The point P, -6, -8, lies on the graph of f. All right, so this was a nice question because we don't actually often examine, test, or consider the inverse function of a parabola, but it is one that we need to learn. So the two important inverses that we learn in matric are that of exponentials, so logs, but also of parabolas, because of the fact that the inverse of a parabola without a restriction is not a function. Okay, so if we had I'm going to work with the parabola that we've been given here. So essentially a negative quadratic function. If we were to take a parabola, terrible parabola, but you get the picture, and we were to take the inverse of it, the inverse of this parabola would look something like this. That isn't a function. And so this is why working with parabolas is so interesting, but also so important to be able to do, because we have to restrict the domain in some way. So we can see here that we were told x is less than or equal to 0. So essentially what that's saying to me is that I am ignoring all positive x values. So all of these x values here I'm ignoring, which means that when it gets to my inverse function, I'm ignoring sort of the inverse of that. So all of those sort of situations over there. Okay, so it's just letting me know what restriction needs to be in place in order for my inverse to actually be a function. Alrighty, as I'm drawing this is not what the inverse would look like. The inverse would be the other way. We're having a time of it. Okay, so let's just fix our inverse. There it goes. Technology is a wonderful thing. Okay. So our inverse would actually look something like that. That's better. Okay. Still not a function, but that's what our inverse would look like. All right. So it's just one that we don't actually often work with, but is one that is really important to be able to deal with. So we've been told that we have a point on the graph, etc., etc. It's all lovely. We can now go and answer some questions. So the first question says, calculate the value of a is the coefficient to x squared. This should be an easy answering, I don't know if that's the right word, an easy question to answer, because we just substitute. We're going to substitute in the point that we have, the -6, -8, because it lies on the graph of f of x, and so it follows the rule. So -8 is equal to a times -6 squared. Remember, negative squared, negative times a negative is a positive. So 36a. We're going to divide both sides by 36. So we would have -8 over 36 is equal to a. And obviously we want to simplify that. We don't want to work with non-simplified answers. It's not usually something we penalize you for, but it makes your life easier. And honestly, just in terms of marking, it is a lot easier when you're working with simplified answers. And you know that in maths, you should always be simplifying. And so this gives us -2/9. Now, remember I said this to you before, I always write down my equation. Even though the question just asked me to calculate the value of A, and I've done that, I'm going to write down the equation of the graph because inevitably I'm going to use that again. So yes, this is not what the question asked of me, but I'm going to write it down anyways because I'm probably going to have to use this again. Right, 4.2 then says determine the equation of f to the -1, so the inverse, in the form y equals. All right, so there's a couple things that we need to remember here. Like I said earlier, the inverse of an exponential we know is a log. The inverse of a quadratic is a root function. So there'll be a square root involved somewhere there. Now we should remember that in order for us to find the inverse, we swap the x and the y. So this equation right now is y is equal to -2/9x squared. We're going to swap those variables. We've got x is equal to -2/9y squared. And then our goal is to solve for y, because as the question asks us to do, it says determine the equation of blah, blah, blah in the form y equals. So we want y alone. Right, so what we're going to do first off is we are going to divide both sides by the -2/9 to get the y squared alone. And so that means I end up with -9/2x is equal to y squared. And so y is equal to, now remember when you introduce a square root, we've got plus or minus square root -9/2x. Right, now there's a couple of things that we need to remember, and this is why I say often we struggle with these sorts of inverse questions with quadratics, because we forget this stuff. So firstly, okay, like I said, when we square root a value, we need to have a plus or minus. That is stock standard. You've been learning that since grade 8 or 9. It's something we often forget. Please don't. So we've got our plus minus there. And then we've got the square root of -9/2x. And now we just need to think logically about this. I cannot square root a negative value. Okay, so the square root of -4 is not possible. That is a non-real solution. So now we have to think about what our restriction should be. So as we saw in the original question, we were given a restriction on our x value. We now need to think what the restriction on this x value needs to be. Now, I can only square root a positive value. So that means that x needs to have a sign that when I times it by -9/2, I get a positive, which means x has to be less than or equal to 0. It has to be negative or 0. That's, again, should be logical to us because a negative times a negative is a positive, or alternatively, something times 0 is 0. And the square root of 0 is 0. So that's the first thing we need to consider. The second thing we need to consider is whether or not we should be considering the positive root or the negative root. So that plus or minus we put in the front, we need to think carefully about it. Now, if you look at my sort of sketch that I drew up here, this is going to help us, and this is why knowing your inverses is super useful. We have been given, all right? So in terms of what function we've been given this section of our parabola. It's super light. You can't actually see that. So let's try that again. Sorry. I was going for something and it didn't do the things. So we've been given this section in green of my original quadratic. An inverse function is when we reflect over the line y equals x. So if we think about that green arm being reflected, that is going to give me the yellow arm. Okay, so this arm in yellow, that's going to be the inverse of that function. What that means is I can now use that to determine whether or not my y values should be positive or negative. Because remember, y equals plus or minus square root. This whole expression here represents my y. So I need to now determine whether or not it should be the positive root or the negative root. And if we look at where this part of my graph is, this is where y is negative. Everything below my x-axis is where y is negative. Everything above is where y is positive. So I'm going to want to go with the negative square root. And so all of this logic and deduction reasoning allows me to say y is equal to minus square root negative 9 over 2x with the condition that x must be less than or equal to 0. And these are all things you have to include. If you don't include that restriction and if you don't recognize that that should be a negative square root, so negative and then the square root, you're going to lose marks. This is only a 2-mark question, so you got a mark for swapping your variables, the x and the y, and then all of those restrictions form part of that final mark. If you don't put those in, you're going to lose that mark. Now, obviously, we know 1 mark and 150 marks is not a huge train smash. However, it is 1 mark difference between passing and failing. So don't make the mistake of forgetting those restrictions and forgetting that information. We need to have that in. And that is particularly important when we work with inverses of quadratic functions. Okay, super, 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 super important. And this is actually why I like this question, because we don't often get tested on the inverses of quadratics. It's more often than not exponentials. And yes, we need to know our exponentials and our logs and all of that, but we cannot forget about the quadratics. Right, 4.3 then asks us to write down the range of this inverse function. Now, again, what we need to remember is that A, you could probably just visualize it for yourselves, but B, the inverse situation is this whole idea of swapping characteristics. And so what that means is the domain of our original function will become the range of the inverse, this idea of swapping x's and y's. So because I'm looking for the range of the inverse, I can go back to the original and consider what its domain is. So this original function has a domain of x less than equal to 0. It is from all values from 0 to negative infinity, which means that now when I write down the range for my inverse, it is y less than equal to 0. And this makes sense. If you think about how we would draw this graph, it would look something like that based on my sketch that I did earlier. And we are having to sketch the graph in the next question, so you'll see this now. The range is from 0 down to negative infinity, and that's exactly what we've just written down as our range. So if you need to draw the graph, if you need to visualize a graph, go for it. But just remember there's a swap. So 4.4 says sketch the graph of the inverse, indicate the coordinates of any point on the graph different to 0, 0. That makes sense. Remember, again, we're just swapping. So all we're going to do is we're going to take this p-value and we're going to swap the coordinates. So this is now going to be at p dash, because remember, it's a transformation of -8, -6. I swapped the x and y coordinates to get that coordinate. That's all I need to do. I've sketched the graph. There's the inverse. There it is. Okay. It follows the restriction x less than 0 that we wrote down earlier. It's all the negative x values. And it follows the thought process of my y needs to be negative. This arm that I've just drawn here, only negative y values. Okay. So again, all of these things we need to remember in terms of, I'm so sorry if you can hear this hammering. I don't understand why it's happening right now. I do apologize. All of these things we need to remember in terms of inverse functions. All right, 4.5, so the last question in this one asks us or says to us that the graph of f is reflected across the line y equals x, and thereafter it is reflected across the x-axis. Determine the equation of the new function in the form y equals. Now, we've had this discussion before, but I'm going to say it again. When you get questions like this, go step by step. There's no reason for you to try and do everything all at once. Go step by step. So this reflection about the line y equals x, we should know that this means the inverse. Okay, anytime we reflect about the line y equals x, we're talking about the inverse. Now, we already have the inverse equation. We've worked it out. It is y is equal to minus root -9 over 2x with our condition x is less than equal to 0. So that is the blue graph that we've drawn. We now want to take this blue graph and we want to perform, or we want it to undergo the second transformation, which is a reflection about the x-axis. Now remember, when we reflect about the x-axis, y changes its sign. Now, if we think, and if we go to our graph and we think about what that would look like, this blue arm that we drew now needs to reflect up and become that green arm that I've drawn there. So it's changing the restriction, or it's changing the y values. I'm going from where y is negative to where y is positive. And so that should now reflect in my equation. We know that originally we had negative square root negative 9 over 2x. Once I flip it over the x-axis, all of those y values are becoming positive. So this is now y is equal to positive root negative 9 over 2x with the same restriction, x less than equal to 0. So all that happens is I'm now working with the positive square root, because I'm now going from negative y's to positive y's. And again, great tools, if you need to draw the sketch, draw the sketch. Like, you use whatever method you feel comfortable with to get your answer. Okay, so let's take a screenshot of all of this. Remember, guys, if you've got questions, you just need to ask. I know you guys will. I'm just kind of going, and when you have a question, I know you're going to ask me, or I'm assuming that you're going to ask me. So please make sure you do. Okay. So like I said, this was just different in many ways because it was starting with an inverse. It was starting with an inverse that we're not really comfortable with. So it was a nice question to actually have a look at, because it's not really one that we've spoken about a lot. We did speak about it when we did inverses, but it's just one that we often forget to go and study. All right. So let's have a look at this question. So I also quite like this paper because this first question, question 5, was not something I've ever seen assessed at a matric level. This is something that we would ask at like a grade 9 level because it deals with rotations. And I suppose it's just whether or not you remember that word. It is only a 2-mark question, so it's really not the end of the world if you don't remember it. I'll be honest, I had to think quite hard about, what happens when I rotate anti-clockwise 90 degrees. But you have learned it. You did it in transformation geometry in grade 9. I just thought it interesting that they assessed it. It's highly unlikely that they'll assess it at the end of the year, but it's come up. No saying it's impossible. So it says the point P2 root 3 lies in the Cartesian plane. Determine the coordinates of the image of point P if P is rotated about the origin through 90 degrees in an anti-clockwise direction. Right, so like I said, this is really taking us back to our grade 9 transformation geometry. So we have got our coordinate P, 2 root 3. Root 3 is about 1.7. So let's call it there-ish. And what we are being asked to do is basically from this origin point, we are being asked to take this coordinate and rotate it 90 degrees. So it's going to go 90 degrees, and I'm going to get a new coordinate somewhere here, P dash. Now, this is very much, do you remember your rules of transformation geometry? What we need to bear in mind is that a 90-degree rotation counterclockwise, remember counterclockwise is the opposite way a clock's hands move, so it'll be this way, is not a reflection. Okay, so it's not a reflection over your y-axis, it is a rotation. Right, and the rule for this rotation, like I said, this is just something that we kind of expect you to know and remember from grade 9. If you rotate 90 degrees counterclockwise, CCW, counterclockwise, your rule is that you take your original coordinate, excuse me, you swap them and you change the sign of y. So it becomes negative yx, which makes sense. You're now on the negative x-axis, so that x coordinate should now be negative. So all that's going to happen here is we're going to take this p dash, so the new coordinate, we're going to swap those values. So now it's root 3, 2, and this value must change its sign. So it's negative root 3, 2. Again, this makes sense. X must be negative. Y remains positive because it is still where y is positive. And that's it. Okay, like I say, it was a bit of a weird question. It wasn't something I really expected, hence why I thought this was an interesting one to go with. So maybe it's worth brushing up on your rotation rules. But honestly, like I don't expect it to come up. It was just an interesting question that popped up in this Gauteng paper. So I thought, let's have a look at it. All right, but let's get into the stuff that we do actually kind of have put a lot of time into studying for. So 5.2 says the graph of h of x is equal to a to the power x is sketched below. A, or the coordinate a, -1/2 is a point on the graph of h. And then we have our questions. The first of which being substantiate why the coordinates of q, the y-intercept of h, are 0, 1. Okay, so we can see q there, put a little blue dot there. Substantiate means give me evidence for why. Show me why. Give me a calculation. Give me something that shows me that it is at 0, 1. Now remember, a y-intercept is where x is equal to 0. So if we take h of x, which is a to the power x, and we make x equal 0, any non-zero value to the power of 0 is 1. Okay, so the y-intercept here is 1, which means that q has to be at 0, 1. So just through basic substitution and your basic knowledge of where a y-intercept sits, you're able to substantiate why that's the case. Right, 5.2.2 then asks us to calculate the value of a. So we're looking in our equation. Again, it is very similar to what we did earlier. We have our equation h of x. We have a coordinate that lies on my graph. So all I need to do is substitute. So I'm going to ask you guys 2 minutes, substitute that in and give me the value of a. You can pop it in the chat. Let's see what we get for the value of a, so our base. Any answers? What is our value for a? No one. No one's got an answer for me. Clearly, we're all in holiday mode. I'm substituting in, so a half is equal to a to the power -1. And there's a lot of different ways that you can now deal with this. I would immediately just change this half to 2 to the -1 equals a to the -1. And remember just the basic fundamental rule of exponential equations. If your bases are the same, the exponents are the same. If the exponents are the same, the bases are the same. Exponents are the same, which means the bases both have to be 2. So a is equal to 2. Again, it's not what the question asked, but I'm going to write it down. H of x is equal to 2 to the power x. I'm probably going to have to use it at some point. Look at that. Next question, inverse function. I need that piece of information. So 5.2.3 says write down the equation of the inverse function, h is -1 in the form of y equals. Again, I'm going to give you 2 minutes to try this one. I'm hoping that someone will give me an answer in the chat for what the inverse is, but let's see how we go. Nice plugging in, Corsi. So exactly, guys. I'm going to show you how to do it, but obviously if you can get straight to your answer, that's absolutely fine. So we know that h is y is equal to 2 to the power x. Again, you're looking for an inverse. You would swap your variables. Y is equal to 2, x is equal to 2 to the power y. And so log of your base 2 to the answer x is equal to the exponent y. Again, if you can go straight to the answer, that's great. There's absolutely no need for you to try and switch. We do give marks for the switch, so there is a mark allocated for swapping your x and your y. However, if you can go straight to the answer with a lot of confidence, there's no real need for you to do that. It's up to you though. But you swap and then you apply your conversion. So the next question says, draw a rough, doesn't say rough. Draw a sketch of the graph of h to -1. Indicate the coordinates of 2 points that lie on this graph. And then I can't spell on this graph. Right, I'm just going to draw this graph on the axis that I have already. You would be given a diagram sheet, so don't stress about it, but I'm going to draw it here. So remember, Q is at 0, 1. If you think back to what I said in the last question, the rule or the trick is that you just swap coordinates. So this y-intercept now becomes our x-intercept at 1, 0. And this coordinate -1/2 swaps. So it becomes a half -1. And so there are the 2 points that lie on this graph. We can draw our function, something like that. and then we have it. Remember, the original function has an asymptote of your x-axis. Swap it around. The asymptote of your inverse is the y-axis. So it should not be cutting your y-axis, and that's how we get our general shape. There's the line y equals x. It's clearly a reflection over that, and so we're sorted. Okay, so again, just think about those swaps. That will help you determine range, domain, coordinates of an x-intercept versus a y-intercept, etc., etc. 5.2.5 says read off from your graph the values of x for which log of 2x is greater than -1. Okay, so these are the questions that we often don't enjoy, but they're not hard questions. We just need to read carefully. So it's asking us to refer specifically to the inverse function, and we're looking where the y values are greater than -1. Remember, log 2x represents a y value. So we want everywhere it's greater than -1. This coordinate here is where y is -1, so that we're using this coordinate as our reference point. And we want where the y values are greater than that. So it's all of these y values above that point. Now that point, because it says the values of x, has a corresponding x value of 1/2, and it will be from 1/2 all the way to positive infinity. So x greater than 1/2. We don't include the half because it doesn't say greater than or equal to -1. It just says greater than -1. So it's just x greater than 1/2. All right, this last question here, g of x is equal to 100 times 3 to the power x. Determine the values for which h of x is equal to g of x. Who can tell me when two graphs are equal, what are we looking for? When we make two graphs equal to each other, what are we finding? Thank you, Bongi and Corsi. The point of intersection. Right, so we take h of x, which is 2 to the power x, and we make it equal to g of x, which is this 100 times 3 to the power x. Now, guys, there's probably a few things that we would want to try. We would probably want to try and make that 100 prime bases, which you could, but your bases there of prime numbers are 2 and 5. So now you're just introducing a whole new base. We don't really want that. So when you have a situation like this where you can't really make your bases the same, what we want to try and do is at least get one x or one term with x. Right now, I've got the 2 to the power x and the 3 to the power x. So what I'm going to do here is I'm actually going to divide both sides by this 3 to the power x, because what it's going to do is it's going to sort of group the terms together that have an x in it. So I'm going to have 2 to the power x over 3 to the power x, which we know we can write as just 2 over 3 to the power x, it means the same thing, is equal to 100. And what this now allows me to do is it allows me to use logs. So log of 2 over 3 over 100 is equal to x. And then we can just type that into our calculator and we can get our answer. So x is equal to, it was like negative 11 comma something. Let's see, now my brain can't remember what this answer was. Negative 11,36. All right. So always just remember, when in doubt, logs, especially with exponents, especially when you can't necessarily get your bases the same. Okay. So I'm just going to, let's take a screenshot of this stuff so far, and then we'll have a look at 5.3, because 5.3 was also a little bit different, not really something I expected in terms of the type of question that we're often used to in functions. But let's see what we get. Okay. So if we look at 5.3, just going to make this bigger again. Like I say, slightly different type of question, but honestly, all just substitution. The price P in rands per unit of each item in a consignment of Q items is given by P equals log 10 plus Q over 2. Now, guys, what we need to remember is that if they don't give us a base for our base is 10. So this is log base 10. Calculate the value of P and the total price of the consignment when the consignment is 1,980 items. Now, remember, Q represents a number of items. So this value that I've been given here is my Q value. So P equals log of 10 plus 1,980 over 2. And you just type that into your calculator. Your calculator does have just a log button without a base placeholder, and that automatically assumes a log with a base of 10. Obviously, you can use the one where it comes up with a little square in the base and you just type in 10. It doesn't really matter. But either way, your calculator does allow you to work with a base 10 without needing to type it in. You chuck that into your calculator and you get that P, which is your rands per unit, is 3 rand per item. They asked us to calculate P, and then they asked us to calculate the total price. Now think about it. Your total price is if you spend 3 rand per item and there's 1,980 items, we just go and work out the total cost there. So it'd be 3 rand times all of the items that I'm buying, which gives me a total of 5,940 rand. All right, so like I said, this question, whilst different, is nothing more than substitution. Literally nothing more than substituting in some values. The last question then says, determine the number of items in the consignment when the price of each item is 2 rand. The price of each item, this is my P value. So 2 is equal to log of 10 plus Q over 2. And now I need to think about how I can go and solve this. Remember, we're looking for an unknown here. We've got logs, so we might very well need to convert back to exponential form, which is what we're going to have to do here. So your base is the 10. So base 10 to the power 2 would be equal to 10 plus Q over 2. We're going to convert back to exponential form. So 10 to the power 2 is 100 equals 10 plus Q over 2. Minus 10 on both sides, 90 is equal to Q over 2 times both sides by 2, 180 is equal to Q. So there were 180 items when my price per item was 2 rand. So this was more just testing your ability to work interchangeably between logs and exponents. But again, different type of question, not something we're used to. An incredibly easy question for 5 marks. But because it's not something we're used to, we get panicked when we see something we're not comfortable with. Right, so again, let's take a screenshot and then we'll move on to the combination type question, which is also one we often struggle with, despite it being grade 11 work. Okay. So this is question 6 in this paper. Sketch below the graphs of f of x equals negative x plus 4 and g of x equals 2 over x plus 1 plus 2. I suppose what's interesting for this question is the fact, is the fact that they give you the equations of both functions. Often we're used to being given a combination question and then it being like g of x is equal to a over x plus p plus q and us having to find a, p, and q and all of that. So that's a bit different here, but nonetheless we go. So the first question says write down the domain of g. G is my hyperbola. Now let's just go back to this function and establish what's happening. So this plus 2 here is my q value. This is telling me that I've moved 2 units up. This expression x plus p is telling me I've moved 1 unit left. My straight line has a negative gradient. So m is negative, which means it's a decreasing function. We can see that. This plus 4 over here tells me it shifted 4 units up. Alternatively, this is my y-intercept. And we can see that over here, they've given us the numbers on the axis, and so we can actually see that the coordinate of A is at 0, 4. Right, so the domain of G, domain refers to your X values. It will be everywhere except for the asymptote that is represented by my shift left or right. So because it's gone 1 unit left, I have an asymptote here at -1. Not my greatest asymptote that I've ever drawn, but whatever, we move. And so my domain is x element real, except for where x is -1. So just bear that in mind. This is just knowing your basics of your graphs. Write down the equations of the asymptotes of G. Well, we've already established what one of them is. And the second asymptote will be dependent on how many units up it's moved because it's gone 2 units up. My other asymptote is at y equals 2. And then we would just write that equation down. 6.3 says calculate the coordinates of D, a point of intersection of f of G and f. So this is where we want to take G of x and make it equal to f of x. So G of x was 2 over x plus 1 plus 2. Okay, I'll fix that now. So it's not looking good. Plus, okay, we're just going to get rid of everything. Okay, so things have taken on a life of its own. Sorry. Right, I am going to ask you to try this one by yourselves. So I do want you to actually please go and try to work out your points of intersection here. This is the equation that you're working with. I would like the coordinates of point D. Right, I'm going to give you, how many marks is this? I think it was 5. I'm going to give you 5 minutes. 5 minutes, 5 marks. I want the coordinates of the point of intersection, please, of point D. Okay, let's have a look. So guys, obviously, again, a few different ways you can approach this. I would try and group as many like terms as possible. So the positive 2 and the positive 4 are like terms. So I'm going to leave the 2 over x plus 1 is equal to minus x. Bring that 2 over, it becomes minus 2, so plus 2. Now, we don't really want the fraction, which means that using inverse operations, I'm going to multiply everything by x plus 1. I'm just going to get rid of my fraction. X plus 1. Okay, and then you're going to have to distribute. So on the left-hand side, I now just have 2. But then I've got minus x times my x plus 1 plus 2 times my x plus 1. Now, what we should remember from doing this previously is that you're going to end up with a quadratic equation. Okay, there's nothing you can do to avoid that. Unfortunately, there is going to be a quadratic equation. It makes sense. There's 2 points of intersection. We should get 2 x values. We already know 1 point of intersection, but we'll get there. So now we put it into standard form. So positive x squared minus x plus 2x is positive x, but then inverse operations minus x. The 2's actually cancel, so we actually just have x squared minus x equals 0. Factorize this by taking out a common factor of x, and we get that x is equal to 0 or x is equal to 1. Makes sense that x is equal to 0. This is my coordinate at A. So I don't need to consider that one. I'm going to work with the x equals 1. To get our y coordinate, we would substitute into either one of these equations. It doesn't matter which one. I'm going to substitute into the straight line just because it's the easier one to work with. And so y is equal to 3, which means the coordinates of D are at 1, 3. And should you need to do anything more with that, which we didn't in this case, you could. All right, so when working with these types of questions, particularly, there was a question. Can't remember where it was now. I've been doing a lot of metric math at the moment, so my brain is a bit fuzzy. But there's a question, or questions often ask you for the specific coordinate of like A and D, or E and F, or whatever. And then we need to be able to look at our graph and say, okay, cool, well, D is not on the y-axis, so it needs to be a positive x value. A is on the y-axis, so this should be where x is 0, etc., etc. We do need to actually be able to interpret the information on the graph. Okay, question. How would you solve it if you didn't take x out as a common factor? In this case, you do have to. It's not possible to solve it without. You do have to take it out as a common factor. There's no other way. What often kids do is, often students will say x squared is equal to x, and then they'll divide by x on both sides, so x is equal to 1, which is a solution, but mathematically that's incorrect. You should never, ever divide by a variable. So that is one way that's like a common mistake that often happens. But like I say, mathematically, that's actually incorrect. It's not, you never divide by a variable. To like cancel away, because then you're forgetting an entire solution. You're ignoring an entire solution. You also don't know, like here, x is equal to 0. If you're now dividing both sides by x, you're actually creating an undefined situation. So whenever you get a quadratic, you need to factorize. Sometimes there are situations, so let's say it was like, I don't know, x squared minus 16 equals 0, then yes, you can say x squared equals 16, square root both sides, all of that. But honestly, factorize. Okay, that would be the difference of squares. You know how to factorize that. So quadratic equations, you should be factorizing. And if you did quadratic and net, sorry, I always forget about the formula. Yes, Layla, you can absolutely do it like that. I always forget about the quadratic formula. So yes, you're more than welcome to use a quadratic formula. And like you say, when it gets to your C value, that would just be 0. So A would be 1, B would be -1, C would be 0. That's absolutely fine. Sorry, I always forget about the formula. I'm useless. You could solve it like that as well. Perfect. All right, so guys, the last little bit, we're going to have a look at some of the calculus questions. I'm not going to look at the first principles one because that is, you either know how to do it or you don't. We will obviously do first principles again when we revise calculus, but I'm going to jump to this question. So this is from the Western Cape trial exam. And there were just a few, particularly this question 7.2.2, there are a few little curveballs thrown that we should be able to deal with, but sometimes we forget. So in these two questions, we're determining the derivative. We're going to use the shortcuts, but remember we've spoken about the fact that you get a first principles question and then you get derivative questions where they are examining you on getting it in the correct format, simplifying all of those sorts of things, and we need to be able to do that. So if we look at the first questions, y equals 8 root x minus 21. We're looking for the derivative, but obviously we need to get the formatting correct first. So I have an issue with the root x. Remember, we don't really want to work with surds where possible. The root 21, I don't have a problem with because there's no variable attached to it. We know a constant derives to 0, so I don't actually care about that, but I do care about the root x. Remember, the square root can be written as an exponent as to the power half. So this is 8x to the power half minus root 21. And so now when I get to my derivative, and please note your notation, you will lose a mark if your notation is incorrect. We'll drop the constant because derives to 0, and now we deal with this 8x to the power half. So the trick is take your exponent times by the coefficient, so a half times 8, which is 4, x, and then you subtract 1 from your exponent minus a half. That is it. 3 marks for getting 8x to the power half, so putting the format correct. 2 marks for your answer, so 4x to the power negative a half, and having no constant there. So basically the derivation to 0. If you really felt this way, you could write this as a surd, so 4 over root x. I don't know why you would want to do that, but obviously I will support you in your choices if that's what you want to do. We don't mark you down for negative exponents in calculus. Leave it. Okay. No point in trying to overcomplicate things. Yes, Leila, so sorry. I just moved. I apologize. Sorry, guys. Let's take a question. Take a screenshot of question 6. I do apologize. Alrighty. Okay, so if we look at 7.2.2, we need to go back to the instructions of the question. And I think this is perhaps where some people had a bit of an oopsie because they forgot what they were doing. We're determining the derivative of the expression y in terms of x. That's what dy over dx is. Take the expression of y, so y equals, and find the derivative in terms of x. And so when we now look at this question, what we need to be able to do is we need to be able to solve for y. I first need to have y equals before I find the derivative. Okay, so that's going to mean or require me to divide everything by x squared. It now makes sense why they've given us this restriction, x cannot equal to 0. If you divide by 0, it's undefined. We're dividing by x. So that's a problem. As I said earlier, we don't divide by variables to eliminate something. That's not what I'm trying to do here. I'm trying to isolate y. So it's absolutely fine that I'm dividing by the y squared because I'm not trying to get rid of anything. I'm doing it so that I can isolate the y. It's an inverse operation. Right, so y is equal to 2x cubed over x squared. I'm going to simplify everything in a second. Obviously, if you can simplify it immediately, go for it. Plus 4 over x squared. So remember, the issue I have here is that I've got x's in the denominator. I don't want that. We never want a variable in the denominator. So now I need to sort that out. In the first term, it kind of sorts itself out because x cubed divided by x squared is then just 2x. But in my second term, I'm going to have to make this a negative exponent. So 4x to the negative 2. Only now that my formatting is correct can I move on to the derivative. So the derivative of my expression y in terms of x is equal to, now we apply our rule. This x in the 2x term has an exponent of 1. So 1 times 2 is 2. And when I subtract 1 from the exponent, it's 0. So the x actually just falls away. So I'm just left with 2. And then I do the same thing with my next term. Negative 2 times 4 is negative 8. X, subtract 1 from my exponent, negative 3. Again, I would stop here. There's no reason to try and go a step further. If you wanted to, you could write this derivative with a positive exponent. So 2 minus 8 over x cubed. We're not going to mark you differently. You're not going to get extra marks if you put it as a positive exponent. So there's no need for you to do that. But if you felt you needed to do it, go for it. Right, 7.3. For some reason, like my kids struggled with a little bit. And again, I think it was maybe just reading of the question. So it said, calculate the value of the constant h so that the curve of y equals hx plus x cubed will have a local maximum at x equals -1. So if we just ignore everything else for a second and we just look at this local maximum situation, remember, this is a turning point, okay? So this would be where my derivative is equal to 0. So I can use this information to now go and figure out what's what. Leila, I do apologize. Sorry, I will show you these mark allocations now. It's one thing I'm really shocking at. I always forget to do the mark allocations. I promise I'll be better when we're getting ready for finals. I will put a little sticky note on my computer. Okay, so like I say, for this first one, you're getting a mark for writing 8x to the power half. I had to put a sticky note when we first started at the beginning of the year because I'd obviously gotten out of a routine. I had to put a sticky note on my computer, press record, because I would just forget to record lessons. I was useless. Okay, so mark for 8x to the power half, and then in terms of your derivative, you're getting a mark for the 4x to the power negative half, and you're getting a mark for root 21 deriving to 0. Deriving. Jeez. So basically not having another term there. Those are your 3 marks. The 4 marks here was for the 2x and the 4x to the power -2. So basically dividing by x squared and simplifying everything. And then your next 2 marks were for the derivatives of each of those terms. So that's where your 4 marks came from. Okay, so like I was saying in 7.3, we know it's a local maximum, so we know the derivative is equal to 0, and we know what the x value would be. So the first thing I'm going to do is I'm going to find my derivative, because that's clearly important if I'm being told that I have a local maximum. Now remember, guys, excuse me. I don't know where I was going with that statement. I'm so sorry. Oh, remember that it says a constant h. So h is just a number. So we actually want to determine the derivative in terms of x. So x is an exponent of 1 here. 1 times h is just h. 1 minus 1, 0. So that just derives to h. The second term would be 3x squared. Great. That is my derivative. I'm now looking specifically at the local maxima situation. So I'm going to take my derivative and I'm going to make it equal to 0. But I've been given even more information in that this local maxima happens at x equals -1. So I can substitute that in and solve for h. So I don't know, this question wasn't well answered. I don't think it was a hard question, but I mean, what do I know? -1 squared is just 1, so h is equal to -3. Like I said, I really did not think this was a particularly hard question, but again, I think it was just reading the question with understanding and then knowing where to go from there. So here, this was 3 marks, a mark for finding your derivative, a mark for understanding that you needed to make your derivative equal to 0 because it was a local maxima, and then a mark for your value of h. Right, so I'm just going to stop there for you to take a screenshot, and then we're going to have a look at the cubic functions question. It was a really nice question because it had the cubic function and the derivative function, which we don't often work with together. So nice to see it. All right. So this was the cubic function question. So in the diagram below shows the curves of f of x equals ax cubed plus bx squared plus cx plus d, and f dash x, so the inverse, equals -3x squared plus 6x plus 9. Then the information, the graph of the derivative intersects the x-axis at a and b. D and E are the stationary points of the cubic graph. And negative 30 is the y-intercept of f. Now, just a couple things to remember, guys. Your x-intercepts of your derivative graph line up with the x values of your stationary points. And you can see that on the graph, okay? So whatever this x-coordinate is of my x-intercept, that is going to be the x-coordinate of my turning point. Same for B and E. That's one of the characteristics of your original and your derivative function. So the first question says determine the coordinates of D and E. And this is exactly leading us into where we're at. D and E are the turning points of my cubic. However, I've got no information about the equation of my cubic function. So I can't go and find the first derivative, make it equal to 0, etc., etc. What I can do, though, because I know that my turning points of my cubic correspond with my x-intercepts of my quadratic or of my first derivative function, is I can go and work out the x-intercepts of the quadratic. So minus 3x squared plus 6x plus 9 equals 0. And like it kind of almost gives it away. It's only asking me for the x coordinates, right? So it's telling me that I need to remember that the x coordinates of my x-intercepts of the derivative graph line up with the x coordinates of the turning points of my original graph. So here I can divide everything by -3 just to make it simpler. So x squared minus 2x minus 3 equals 0. At this point, if you want to use a quadratic equation, absolutely go for it. I'm just going to factorize though. X minus 3x plus 1 equals 0. And so x is equal to 3 or x is equal to -1. This was the question I was thinking of earlier. It said the coordinates of D and E. So now you actually kind of need to tell me which one's which. Look at where D is. D is clearly where x is negative. So -1 and then some y coordinate for D. E is clearly where x is positive. So E will be at +3 and some y coordinate of E. Right, so this first question immediately testing whether or not we know the properties of your derivative function and its relationship with your original. Right, 8.2 then asks for the equation of f. I will show the mark allocations in a second. The equation of f, so the original cubic function. Now I'm going to show you the way to do it using the information that we have, and would be the way that you would do it. But you could use the opposite of differentiation. We call that an integral or anti-differentiation, which I'll show you in a second as well. All right, so first things first, we know that f is ax cubed plus bx squared plus cx plus d. And we know what the derivative function is. We know that the derivative function is -3x squared plus 6x plus 9. Those two are linked. It's the derivative of your original. So if we go to this f of x function and we find the derivative in terms of a, b, and c, all right? So we're going to go find the derivative here, giving me 3ax squared plus 2bx plus c, because remember that constant derives to 0. We know that these two derivative expressions are the same thing. They represent exactly the same graph. And so what that means is that 3a, my coefficient to x squared, has to equal -3. I know that in the same vein, the coefficient of x to b must represent 6. And I know that c must represent 9. So you can use the fact that you've got an algebraic derivative in the actual equation to go and work all of this stuff out. So that means we would take 3a and equal it to -3, meaning that a is equal to -1. We know that 2b must be equal to 6, and so b is equal to, don't know why that took my brain so long, 3. And obviously c is the constant, so c is equal to 9. We were told in the information of the question, -30 is the y-intercept, and so d is equal to -30. And so f of x is equal to minus x cubed plus 3x squared plus 9x minus 30. Right, and this should be the way most of us would go about doing it. But like I say, technically, you could go and work backwards from here. And that's called an integral. We don't actually talk about integrals anymore. If you do AP Maths, or if you've ever seen AP Maths or FS Maths, integrals kind of come in there a bit more. And you do them at university if you're going to take maths in university, but we don't really focus on it. Okay, so if we were to go do the integral, basically we need to undo the differentiation, the derivative, okay? So what that would mean is that this x squared term was derived from my x cubed term, okay? And we would have to work backwards from there. This 6x term was derived from my x squared term, and this 9 term was derived from my x term. And obviously I know that my d term is negative 30 because of the information given to me. So you could work backwards from this point and go and get what you needed to get. So for example, just because my brain's working like this at the moment. For example, this 9 term, we know that this would have to be 9x. Why? Because if you take the derivative of 9x, 1 times 9 is 9. Derivative of the variable by itself is just that. If we go then to the 6x term, we know that we would have to have said 2 times something in front to get 6. 2 times 3 would give me the x squared term. And then we would use the same logic here. 3 times something in the front of this would need to give me a coefficient of negative 3, which means it needed to be negative x cubed. Nope, minus 30. And you get exactly the same equation. So whether you use the integral or anti-differentiation, integral, or you go and actually use the derivatives and line them up, whatever, it's up to you. I would have done the first method that I've done in the lighter blue personally. But if your brain works that you can do the antiderivative / integral, that's cool. There's no problem with that whatsoever. Right, so your mark allocation here. So this first question was for 3 marks. So understanding that you needed to take your derivative, make it equal to 0, factorizing and getting your solutions. Sorry, I don't know what happened there. The 5 marks here, getting your derivative algebraically, essentially matching up the coefficients, getting your A, your B, your C, and then getting your equation with D as negative 30. So C4, yes, you would still get your 5 marks. So your 5 marks here would quite literally be for the A, the B, the C, and then a double mark for the equation. So you still get all 5 marks if you use the integral. Excuse me, there's nothing wrong with it. Okay, you're not making an assumption about anything, nothing like that. It's absolutely fine. So you get your A, B, C mark, essentially your D mark, and then putting it into an equation. Okay. Like I said, I wouldn't have used it, but I think that's just because my brain wouldn't have initially thought to use the integral. But that's just my brain. Okay. So let's have a look at 8.3. So 8.3 is asking us to determine the value or values of x for which f is increasing. So f is my cubic function. My cubic function is only increasing in between these 2 turning points. I can't highlight, but you understand what I'm trying to say. Because we have established where these 2 turning points are, now remember this is D at -1 and then some y coordinates. This is E at 3 and some y coordinates. We have the x coordinates. We have the x values. Okay, so we can go from there. Okay, now I'm panicking. Yes, this is where it's increasing. Sorry. So this is where the graph is increasing, and we go and say it would be from -1 all the way up to 3. We don't include those two values because those are my turning points. So that would be where my graph is equal to 0, or the first derivative rather of my graph is equal to 0. So we don't include them. Just quickly, if it was where the graph was decreasing, this would be this arm of my cubic here, and then the arm of my cubic here after and before the turning points. So this would be x less than -1 or x greater than 3. So just always think about where your graph is going down, going up, going down. Obviously, if this was a positive cubic, it would be increasing, decreasing, increasing. Not like whatever that cubic I've just drawn is. So let's just get rid of that because that's embarrassing. Right, and then 8.4 is asking us where or which values of x is the graph concave down. Concavity is our second derivative. Point of inflection is the exact moment where your concavity changes. Basically, what that means is on your cubic function, these tangents will all sit outside your graph, and there comes a point where it now swaps over to the other side, and your tangents then sort of flip over. The exact point where that flip occurs is your point of inflection. It's where your concavity changes. Your point of inflection is if you wanted to if you wanted to determine it, would be where your second derivative is equal to 0. We want where it's concave down. Concave down would be the sad face portion. Okay, so concave down is where it looks, how do you spell, oh gosh, down, sorry. It looks like a sad parabola, that portion of your cubic, and this is where your second derivative is less than 0. Concave up is where it looks like a happy face greater than 0. Now, there's a few different ways you can answer this question. I would just use this, the second derivative equal to 0 idea. So I know that I'm looking for concave down, which is where my second derivative is less than 0. I know that my first derivative is equal to minus 3x squared plus 6x plus 9, which means that my second derivative is equal to negative 6x plus 6. So now I can just take that expression. Make it less than 0, and solve for x. So negative 6 is less than negative 6. Negative 6x is less than negative 6. I'm going to divide both sides by negative 6. And remember, grade 12, that means my inequality sign flips. So x is greater than 1. Now, this kind of makes sense. If we go and look here, x equals 1 is about there. Okay, obviously I'm making a wild assumption, a 1. That kind of looks like where the point of inflection may very well be and where concavity may change. And so in terms of my answer, it does make sense for the graph I've been given. So just remember concavity, second derivative. So 8.3, we've had this discussion before. I don't know if they've changed their marking. I don't know. I will have to see when I mark in finals and then go from there. But it was quite interesting that for the trial papers, and like I said, I'm just speaking for the Western Cape. I don't know about other provinces because I wasn't part of those memo discussions. But it was quite interesting to me that usually an inequality question, it's all or nothing. So you have to get everything right to get 2 marks or you get it wrong. However, this time they gave you marks for your critical value. So understanding it was between -1 and 3, and then a mark for your inequality, or if you're using interval notation for your brackets. And this happened in a lot of different scenarios. So the functions, it happened even in paper 2 for like trig functions and all of that. I just found that interesting. I don't know if it'll be like that in the finals. And I've said this to you guys before, most of the time it's an all or nothing mark. You have to get it perfectly correct to get full marks. Otherwise, it's 0. So please just bear that in mind, that even though, like I say, this time it seemed that the marking was like this, please don't assume it's going to be like that at the finals. Just assume all or nothing. And then this question, understanding your second derivative, making it less than 0, and getting the appropriate x value for your concave down situation. All right, so this was the calculus graph question, or yeah. And I did think it was quite a nice question in terms of assessing pretty much everything that you needed to know, and also working with the derivative function. And like I said, there were a few different ways that you could have done some of these questions. Just depends on where you're at. But yeah, I did think it was a very nice cubic function question. I thought it was an easy cubic function question, but only easy if you knew your stuff. So if you didn't know the derivative function and its relationship with x-intercepts, you were going to go wrong. Do the markers accept corrective accuracy in finals? Are you going to, what does corrective accuracy means? I feel a bit stupid right now. Like CA, is that what you mean? Like CA marking? Yeah, okay. Sorry, it's been a long day. And I also call it continue accuracy, but it means the same thing, I suppose. Yes, so we do CA mark. So guys, CA marking, corrective accuracy or continued accuracy, basically means that if you screwed up somewhere that then requires that answer, we're not going to penalize you twice. So for example, it'll be somewhere in a functions situation. Okay, so let's say, for example, here, in 5.2.2, you had to work out the value of A. Now, let's say you messed that up and you got a half, for example. When you now have to use that equation here in 5.2.6, and you had then said a half x is equal to 100 times 3 to the power x, I will give you 4 marks if you have correctly used the appropriate methodology, but with the incorrect value. So you'll lose marks here in 5.2.2 because obviously you've done something wrong here. But then if you use the wrong answer correctly, you can still get full marks. So yeah, we definitely do. We won't penalize you. We'll penalize you once for the mistake, but we won't penalize you again for it.